In this video, I'm going to go through how to interpret the one-way ANOVA results. I'm going to talk about post-hoc tests with this as well, even though for this test, for this specific example, they're not necessary. So first of all, this is where we start. You always start with your overall model test, which is your omnibus test. So we're looking for all over, are there any differences in self-efficacy across these different conditions anywhere? So we have to think about, we have three conditions. So there's combinations of pairs that we could compare. So we could look at the Zen acceptance versus the depends on the situation. That's one pair. We could look at Zen acceptance versus panic mode. That's another pair. This test doesn't tell you the results for that. It just says overall, are there any differences? And so we look at that, and how we make that decision is we look at the p-value. So the p-value for this overall model tells us that it's pretty likely that if the null hypothesis were true, if there really were no differences in academic self-efficacy for these different groups, it's pretty likely that we would get this size of a difference or even bigger difference, even if the null hypothesis were true just by chance. So this is most likely sampling error because our p-value is greater than 0.05. The rule is, p-value less than alpha. So if the p-value is less than 0.05, we would reject it. We're not going to reject it. We're going to fail to reject our null hypothesis about the overall test. So other important information here. We have our degrees of freedom between, which is the number of groups minus one. So there's three groups in this pop reaction variable. So 3 minus 1 is 2. And then our within groups degrees of freedom is n minus k, which is the sample size minus the number of groups. So we had 35 people minus 3 groups equals 32. And then our F statistic is a ratio. The F statistic is a ratio of the variation between the groups divided by variation within the groups. And so the idea is we're really looking to see what's the real difference between the groups if we account for variation inside the groups is the simplest way to think about that. We also have the eta-squared effect size. Again, you can do omega squared, which is this little squiggly W down here. It's a little more conservative of an estimate. I just typically see more people reporting eta-squared. So that would be up to you. But for this one, we can see that the effect size or the size of the effect of the independent variable on the dependent variable is just barely considered medium by normal standards for that. But it's not significant. So again, we think that we just happen to find that difference because of sampling error. I do want to mention that effect size, it's not talking about cause and effect. We're talking about relationship size. So make sure that you're not interpreting this as an effect on it unless you are able to talk about that through your research design or through controlling for other variables. Okay. So that's the overall model. Now, if that p-value were significant, which I showed in the video showing how to conduct this test, you would also talk about pairwise comparisons. And so I just wanted to show you how that works. I do have the repeated measures ANOVA videos that does have a significant overall model. And so you can always refer to that if you want to. So here you can see I added these post hoc comparisons. And what we're doing is we're looking at individual pair scores. This is the T statistic for each pair. And so how that works is you can see that top row says panic mode and then Zen acceptance, and then it has a T score, and it's for the relationship between those pairs of categories. And then our P Tukey is our P value for that pair. We also have a Cohen's D for that pair. So we can see here that panic mode, Zen acceptance, we do not have a significant relationship between those variables because it is not less than 0.05. So we're going to fail to reject. Same thing here. There is no significant difference between panic mode and depends on the day. and there is no significant difference between Zen acceptance and depends on the day. So it just tells us all of the details for those different tests. So again, this isn't necessary. We don't need to show this information because the overall model is not significant. I do just want to point out that you'll notice that there's this negative value right here, and then this is a positive value. So the negative just means that this first one, panic mode, had the lower score for self-efficacy. And then that negative just means that that's the smaller group. Same thing here. Panic mode is lower than depends on the day. And then Zen acceptance is positive. So that means that it's a higher score than depends on the day. Descriptively, there's no significant difference. So again, we just say that that difference is sampling error, and we do not refer to them as different. So that's all I have for this video. And then in the next one, I'm going to go ahead and go through how to conduct or how to write this out in APA style.